Good morning, good evening, good afternoon. My name is Keith Pascal with the Open Tech Support Team. Today we're going to talk about the installation of Solr. Before we talk too much about installation, we need to look at prerequisites. For Solr, the OS that you need is Linux, macOS, or Windows. The Java that you need is JDK 1.8 or higher. The memory is whatever the operating system uses plus 4 gigs. And that's to start with. And you do see an asterisk on that, which I'll explain in a minute. You need a dual core CPU and more than 80 gigs of disk space. Now, those 3 asterisks, they just are a disclaimer that it depends on your use case. Scaling Solr systems is relatively straightforward, and it allows for the addition of nodes and memory allocation based on performance evaluations. There's no rigid guideline for scaling Solr systems. Instead, it's a matter of evaluating the performance and then adjusting it accordingly. Let's get on with installing Solr. Before we do, first and foremost, let's proceed with the installation of the essential tools that are required for, in this case, Red Hat Linux. First, the package of net tools is installed. That is the command line installation for it. Net-tools is needed for netstat, which is a good troubleshooting tool that will allow you to see what ports are being utilized, right? The other thing here is wget. Wget is a command line utility utilized for retrieving files from URLs and then saving them as binary distributions on the system. I employed this tool to download the appropriate version of Solr for the system. Another critical tool that we will need is LSOF. LSOF stands for List Open Files, which helps in identifying processes listening on a specific port and provides insight into various file activities. It's also noteworthy to say that we require Java 1.8. For this version of CMS, UCMDB, Universal Discovery, we're currently supporting Solr version 8.11.2, and that does require Java 1.8. Next, let's get Solr. So to get Solr, we're going to use the tool we just downloaded, wget, for this URL to grab the Solr 8.11.2.tar.gz, right, or .tgz. This is me running the command, and it's saving it to the temp directory on my system. Next, we need to extract Solr and set some directories with config sets. Now, we'll need to proceed to extract Solr. It comes in a .tgz file, so it's crucial to create the Solr directory for indexing purposes. To accomplish this, we'll navigate to the opt directory. Then we will unzip the tar.gz file, and that is the tar xvf command. Additionally, we will then go ahead and link Solr-8.11.2 to the Solr under opt. I did this because it makes it easier to administer Solr if you need to do upgrades or that kind of thing. We also do a makedir for Solr index and Solr index Solr. Then I'm going to take the configsets.tar that I created from my UCMDB server and put it in the opt Solr index Solr directory. The config sets are found on the UCMDB server in the search directory. There's a config sets folder. Just put that folder into a tarball, transfer it to your Unix box, and then I put it in the temp directory on my Unix box and then extracted it to the opt Solr index Solr directory. Next, we need to edit the security.json file. The security.json file controls access to the Solr user interface. This file dictates the credentials that we're going to be using to access that interface. By default, the username is Solr and the password is SolarRocks with a capital S and a capital R. But these values are managed within the security.json file. This file is just formatted JSON and conveniently provides the necessary structure for defining user credentials. You can observe that the credentials specified as Solr along with the hashed representation of SolarRocks. If you wish to set different credentials, instructions are available for generating the hashed password, which can then be included in this file. Alternatively, the hashed password is also provided in your solr-in.sh file. Next, we need to configure solr.xml and solr.in.sh. The solr.xml file provided by UCMDB lacks the necessary Solr Cloud configuration tag, rendering it incompatible with the Solr Cloud environment. Therefore, it is recommended that you use the default solr.xml that comes with Solr itself. This default file contains the required Solr Cloud configuration and will function properly in a Solr Cloud setup. However, the critical component to focus on is the config sets. They contain numerous XML files dictating various aspects such as data download, indexing criteria, ranking, and parsing. It's important to note that we're not storing these configurations in a manner typical of a Zookeeper administration. As previously mentioned, Zookeeper operates like a distributed file system, allowing files like the solr.xml and security.json to be uploaded to Zookeeper. Consequently, when you're adding a new Solr node, it can retrieve its configuration directly from Zookeeper upon connection. Within the solr.in.sh file, which serves as the configuration startup file for Solr, you need to have the flexibility to adjust the memory settings as needed. In this instance, I've configured it to allocate a minimum and maximum of 2 gigabytes of memory. Additionally, I made a modification to set the ZK hosts to the Zookeeper hosts along with their respective ports. Here, ZK denotes the word Zookeeper, and each host is designated with the format Zookeeper1:2181, where 1, 2, and 3 are actually separate instances of Zookeeper. If you need, you can modify the etc host file on the Solr system to give the IP addresses of the Zookeeper 1, Zookeeper 2, and Zookeeper 3 servers to make it easier to administer the Solr installation. Furthermore, I've configured the Solr auth type as basic and the Solr authentication options to Solr and SolarRocks. We can optionally increase the max open files and processes. When starting Solr, you may encounter numerous warnings regarding file system limitations, specifically concerning files and process limits. However, you can address this by increasing these limits. Solr still can function adequately with the default limits in some cases, unless you're operating in a significantly large environment. By default, the file limit is set to 1024. Solr has the potential to create a substantial number of files, particularly when dealing with large volumes of configuration items. Each CI type and individual CI has its own configuration stored within the Solr search engine. So as long as the file limit doesn't exceed 1024, you shouldn't encounter issues. It's worth clarifying that the limit refers to 1024 CI types, not individual CIs. Next, we can start Solr. So to start Solr, run the command as follows: sudo solr bin solr start-c-s solr/index/solr-p8983-force. This will start the Solr server. The -C is for cloud mode. We don't need the -Z because we specified the zk_host in the solr.in.sh file. The -S directory is used to indicate where Solr home is at. The -P is the port number to use, and the -force is the ability to run at root. If running as non-root, ensure the file permissions in OpSolr are changed so that the user can modify and write files. Optionally, -H specifies the host name for the Solr server, and -F starts Solr in the foreground, which is very good for troubleshooting, especially permissions problems. Next, we'll check the status. To do this, we'll run sudo bin solr status. That will give us the following output. When I run this, I will see what the process number is, what the port number is, Solr home, the version that we're running, when did we start, how long has it been up, how much memory is it using, and then in the cloud configuration, you'll see which Zookeeper servers we're using, how many live nodes there are, and how many collections. Collections can also be called cores, and for UCMDB, generally speaking, you have 2 different cores. Now, it is worth noting that UCMDB can only connect to a single Solr farm. For instance, if you have 3 Solr systems set up in a Solr cloud with Zookeeper on the front end, because UCMDB will name the cores after the customer numbers. And so because all UCMDB servers have a customer 1, those cores would overwrite one another. And so they need to be in separate Solr farms. And it's a good thing that Solr doesn't require many resources, so that should not be difficult. Now, Solr is installed and running. Thank you very much for your time. Have a fantastic day.